I've had a couple questions in regards to why are there negative numbers when we're doing some mixed integer programs or integer programs. So I'm assuming you're talking about the Hart Manufacturing example that we did earlier in the week, where I told you to introduce binary variables. And so it should have started something like this, or this is something that you should have ended up with, right? So the negative numbers up here in the objective function row should be intuitive. Those are the cost, the setup cost, right? So they have to be negative because these right here were profit numbers. So to maximize profit, right, we'd have to take out the cost. So those negative numbers should be relatively straightforward. I'm assuming you're talking about this down here, the max production. You're wondering why this is a negative 160, why this is a negative 120, negative 125, right? That's what I'm assuming the questions are asking about. So that's what I'm going to answer. So if we go to this, right, it says management stated that we should not consider making more than 160 units of product 1, 120 of 2, and 125 of product 3. And if we go back to here, we see negative 160, negative 120, negative 125. It's not a coincidence that those numbers are exactly the numbers that are the maximum. So if I were to write out the constraint, which is probably the best thing you should do, right, what you're saying is, remember we defined, if we go back up to here where I had the original formulation, we defined P1 as the number of units to produce during the next production period, right? So we're saying if we do decide to produce product 1, it has to be less than or equal to 160. So the way to enforce that is with the binary variable, which I told you to define as y, right? So we're saying P1 needs to be less than or equal to 160 units, but that's only true if we actually set up for product 1. So we set up for product 1 for y1, right? So what this is saying is if y1 equals 1, set up and produce up to 160 units. You can still produce 0, but that would be ridiculous if you set up and incur the cost, right? If y1 equals 0, do not set up, and P1 is then forced to be 0. So substitute 0 in for y1. 160 times 0 is 0, so P1 is going to be less than or equal to 0. It has to be 0 because it also has to be greater than or equal to 0. So that forces P1 to not be produced at all. So that's what that constraint's doing. So how did I get to the negative 160? Well, this guy is just the same. Ooh, didn't know it would do that. Right? So you move all the variables onto the left-hand side. So P1 is on the left-hand side already. How do I get the y1 onto the left-hand side? I subtract it from both sides. So then it's a minus 160 y1 less than or equal to, nothing's left on the left-hand side, on the right-hand side. So then this is the constraint that you see in Excel. There's a 1 in front of the P1, a negative 160 in front of the y1, and a 0 on the right-hand side. So that's what we're doing when we're doing these constraints with the negative. So hopefully that makes sense to you now, and you can understand it better.